Okay, let's solve a sample problem here regarding consolidated drain triaxial test under the shear strength of a soil sample. So we have a triaxial test on a cohesive sample cylindrical in shape yield the following effective stresses. We have the major principal stress 8,000 kilopascal, minor principal stress 2,000 kilopascal. The angle of inclination of rupture plane is 60 degrees with respect to the horizontal. We are required to find these requirements: the deviator stress, the angle of friction, and the cohesion of the soil sample. Okay, so to solve this, drawing natin more circle natin. Since meron tayong cohesion na kinukuha, the intersection of our failure line nandyan. Wala sa ating origin. Para magka-value yung cohesion, nandito siya. That is C prime. And let this be our Mohr circle. We have the major principal stress or maximum normal stress. This is the point of maximum normal stress, 8,000 kilopascal. Minor principal stress or minimum normal, ito yung point nun, 2,000 kilopascal. And also given yung value ng theta natin, that is 60 degrees. Okay, first requirement is the deviator stress. Deviator stress is just the diameter of the Mohr circle. As you can see, makukuha natin yung diameter. That is deviator stress at failure. That is equivalent to 8,000 kilopascal minus 2,000 kilopascal, 6,000 kilopascal. First requirement. We analyze natin yung Mohr circle natin. That is the center. This is the radius. Diameter is 6,000. Radius is 3,000. 3,000. 3,000. Therefore, yung center natin is at 5,000 kilopascal from the origin. Okay, next one, angle of friction. The angle of friction, meron tayong relationship nun with respect to the value of angle of failure. That is theta equivalent to 45 plus phi prime over 2. And that is equivalent to 60 degrees, equivalent to 45 plus phi prime over 2. So, computing for phi prime, that is 15 times 2, 30 degrees. Second requirement. Third requirement is the cohesion of the soil sample. Para ma-solve natin cohesion, gamitin natin mismo yung ating Mohr column criteria of failure. O pwede rin tayong mag-base dito sa triangles. Gamitin lang natin mismo at this time, for this time, yung ating Mohr column criteria of failure. That sigma 1 prime is equal to sigma 3 prime tangent squared theta plus 2c prime tangent of theta. Sigma 1 prime is the maximum normal stress, 8,000. Equivalent to sigma 3 prime, minimum, 2,000. Tangent squared, angle theta is 60 degrees plus 2c prime tangent of 60 degrees. So, mapapansin sa ating equation, iisa lang yung unknown parameter natin, which is the cohesion. And we can get a value of cohesion equivalent to 577.35 kilopascal. And that will be the requirement for this given problem. Additional question lang po, pwede rin itanong dito yung point of failure natin. Point of failure is the point of tangency. Ito yun. Kung pinapatanong sa problem yung normal stress at failure tsaka yung shear stress at failure. So, para makuha yung point na yun, we will just analyze this right triangle. So, ihiwalay lang natin. Let this be the right triangle. If this is phi prime, this is also phi prime. Therefore, itong angle na to ay 30 degrees. This is the radius, 3,000 kilopascal. Let this be x. Let this be y. By trigonometric functions, sine function 30 degrees is opposite x over the radius 3,000. So we can compute x equivalent to 1,500 kilopascal. Therefore, makukuha natin mismo yung normal stress at failure. From the origin up to this point, nandyan yun. So, para makuha natin yun, center to 5,000, ma-minus lang natin to, which is the value of x, para makuha yung normal stress at failure. That is C minus x, or 5,000 minus 1,500. And that will be equivalent to 3,500 kilo Pascal. For the shear stress at failure, eto siya. The value of y. Para makuha natin yung value ng y, which is the shear stress at failure, that is by taking cosine function. That is 3,000 cosine of angle 30 degrees. And that will be equivalent to 2,598.076 kilo Pascal. And that will be the requirement for this given problem.